Okay, so I'm going to try to solve this mean variance standard deviation calculator. I looked at Landon's solution, but I only looked at it briefly. I looked at Landon. So it seemed easy, but yeah, I already did this part here, and I read the problem already. But pretty much the way that it works, you receive a list of 9 by 9, 3 by 3 matrix, and then you have to return this object here. So you need to calculate the mean mean variance, standard deviation, max, mean, sum. So here I created NumPy array. I believe that's how you create one. And here I created this error in case the list is different than 9. The length of the list is different than 9, which means that the matrix is not 3 by 3. So now I have to see how to create each thing. Not sure if I should do equal or like this. And it's not so clear to me, but from what I saw from Landom, I think that should be the mean of the axis 1, this the mean of the axis 2, and this is the flattened one, which is the mean of the whole list. Return a dictionary containing the mean variance, standard deviation, max mean. So I believe that in order to get the mean, you should do mean, something like that. And then you need to get the index. But I'm gonna research this.
Okay, so what we're going to look at now is how to create a mean calculator. Basically, what the mean is the average of a group of numbers. I'm sure all of you know that by now. But what we need to look at right now is how to create a function to return the average of a list. So basically, what we want to start out is by declaring our function, and we're going to call it mean, and it's going to have a parameter of values. So what we first need to figure out is the length of the list. So what we're going to do is we're just going to create a variable named length, and we're going to set that equal to len, which is one of the default functions of Python, and it's going to be the length of values. So now we need to create a variable to keep track of the total sum of all the numbers in the list. So first of all, we declare our variable as total sum, and we're going to set it equal to 0. So now we need to make a for loop so we can go through all of the numbers in our list. And the syntax for loop is for and I, and then we're going to say in range, and the range is length, or the parameter for range is length. So what this does is create a list of numbers based on the length.
The NumPy mean and average functions are used to calculate the arithmetic mean across the flattened array or specified axis. These two functions are equivalent, except the average function takes an optional weight argument, which is not available in the mean function. To use these functions, we will create a new script with the NumPy library imported as np. Next, we will create a new variable called values and set this equal to np.arrange. Within the arrange function, we will add the integer 12 as the first argument, and then the reshape function will be chained on after the arrange to create an array with 4 rows and 3 columns with values from 0 to 11. To use the mean function, we will call np.mean. Within the mean function, we can pass in our values array as the first argument. When the result is printed to the console, we see the function has taken the mean of all the elements within the values array, which is 5.5. The mean is calculated based on the flattened array by default, but we can specify an axis to calculate the mean over using the axis keyword as the second argument within the function. We will assign the integer 0 to the axis keyword, and when the result is printed.
So guys, is like this, but instead of this, you make it like this. on axis equals 0. Why is this not working? That's weird. I assume the answer is gonna be something like this. And here is gonna be list. And here is gonna be the values that are not on the other one. It's just not so clear to me what these first lines are supposed to be. Because if it was the mean, it would be just one number, but here is showing up a list instead. Maybe it's supposed to be the same values that they show up there.
Printed to the console, we see the returned array contains a mean value that has been calculated over each column within the values array. Similarly, we can specify the integer 1 for the axis keyword, and the returned array will have the calculated mean values over each row in the array. We will create a new variable called output above the mean function and set this equal to np.zeros, with the integer 4 passes the first argument to the zeros function. Now we will add the out keyword to the mean function and assign the new array output to the keyword. When the output array is printed to the console, the results from the mean function are output to the new array. The average function is very
Oh god, it's the other way around. Here should be NP, I think. And here's LP. Still maybe if I do this, it works. Yeah. And I think the other ones are gonna be pretty much the same thing, but just change the method. Oops. So there's variance. Standard deviation. Max. Mean. Sum. Should be underlined here.
similar to the mean function. The first argument we will pass in is the values array, and the axis keyword will be assigned to the value 0. The average function computes a weighted average along the specified axis, which can be done through the weights keyword. The weight in the average function indicates the weight that each value contributes to the overall average. We will call the average function using np.average and pass in the second row of the values array using the index 1 within square brackets as the first argument.
Because we can make it like this. Don't need the comma here.
To the average function. Next, we will add the keyword weights and assign this to an array with the values 0.5, 1, and 4. When the script is run, we see the weighted average is now 4.63. This is calculated by multiplying each weight by its value within the array, adding up each product, and then dividing this total by the total sum of the weights. In this case, the weighted average is the quotient of 25.5 divided by 5.5. If we would like to see the sum of the weights, we can add the keyword return within the average function, and the result that is printed to the console is a tuple containing the average value and the sum of the weights within it. For more Python tutorials, like, share, and subscribe to the PyPros channel.
Hello everyone. This video helps bring clarification on how and when to use the access function for NumPy arrays and pandas data frames. So let's get started. A simple way to remember this idea is to think of a log as either a data frame or a NumPy array. How you cut the log using an axe will help you remember the concept of access equal to 0 or access equal to 1. Let's start with access equal to 0. A simple way to remember this is to equate 0 with a down. Think of it as chopping a log using an axe into two vertical pieces. Each row element of the column is transformed using a function when you apply access equal to 0. Similarly, when you say access equal to 1, a simple way to remember this is by equating 1 with a cross. Think of it as chopping a log using an axe into two horizontal pieces where each column element of the row is transformed using a function when you say access equal to 1. Let's look at an example on how access is used in NumPy arrays. I first create a NumPy array with 2 rows and 3 columns. In the first case, when I say access equal to 0, I apply the sum function on all rows of the columns. Think of it as chopping the log into 3 vertical pieces and then finding the sum of each piece. Thus, if you now consider the first column, which is 1 and 4, I calculate the sum of the first column, which is 5. Similarly, the sum of second column is 7 and the sum of third column is 9. And this is how I get the sum function when I do access equal to 0. When I do access equal
I'm pretty sure these values have to be different as well. But I'm not
to
exactly sure
1,
why.
now I'm chopping the array into two horizontal parts and calculating the sum for each individual part. So in our case, the first part would be the sum of 1, 2, 3, which is 6, and the second part, which would be the sum of 4, 5, 6, which is 15. This is how access is used in NumPy. And a row-wise mean for the first column. Make use of access equal to 1, which gives me mean for the first row. If you see the first row carefully, the values are 1 and 3. The mean of 1 and 3 is basically 2. So using access equal to 1, I get a row-wise mean for all columns which are present. So this is how you make use of the access function. Hope now you won't ever make a mistake in using the access function wisely. Thanks for watching the video. Do subscribe to the channel to enjoy more such amazing
Well, I guess I understand. It wants me to do the mean of each column and each row. That's why there's 3 numbers there. So the first 3 will be 0 plus 1 plus 2. No, but that's not the mean. That's this one. So it's the other way around. It's the row here and the column here. Yeah, 0, 4, and 0, 0, 3, and 6 should be 3. So first is the column, then the row. Then I have to think about how to get the indexes.
videos.
guess. So here's the column, so it should be 0, then 2, 3, and 6. But that doesn't make sense. Oh yeah, I'm giving the axis here. So 0, I guess, is columns. Yeah, so here's 1 plus 3 divided by 2. So x is 0 is equal to column, and x is 1 is equal to row. So that should be 0, 1, 2, I think. Because it's the first column, the second, and the third. Then row has to be 0, 4, 3. Yeah, and 7. Because it's the start of each row, I think. So maybe here S should be LP. Same thing.
Hello YouTube, welcome back to my channel. So in this tutorial, continue with our series on Introduction to Statistics for Machine Learning. In this tutorial, we're going to look at variance. So in the last tutorial, we looked at deviation. So in this tutorial, we're going to look at variance. So variance is also called the mean squared deviation or the mean squared error. So this is how spread out our data is. So that's what variance tells us. How dispersed our data is from the mean, from the central point. How far is our data spread out from the central point, which is the mean. Okay, that's what variance tells us. So variance is also called the mean squared deviation. So in the last tutorial, we looked at deviation, and you might notice this is a formula for deviation, right? The value minus the mean of the whole data set. So the mean, which is average, squared deviation. So the deviation is squared, and then you find the mean of the deviation. Again, there's a fraction, there's a line here, but this doesn't show. So you just exit slide mode, and you can see that's the formula right here. So that line is over there. Okay. So now let's go back to presentation mode. Okay. So this is the formula to calculate variance. Okay. So there are two formulas. So there is that the first one, which with the denominator is it has n minus 1, and there's a second one where everything else is the same, but the denominator is n mated. So now let's go ahead and actually see how we can. Now let's try to see how we can calculate the variance of the data. So you can see np.var, which is the sense for variance, short for variance, and here you can pass in our data. So you can press that, and then you can see we have this is the variance of this data set. So this is the variance of our data. So now that we have the variance, let's try to. So this tells us how spread out the data is. So let's do something. Let's change from 4 to call it before. It's 6,530. Remove this cell as well. So also remove this cell. Then this will be this formula will be see the degree of freedom becomes this one. So our value gets underestimated, and we have.
Welcome. Today we are going to learn how to calculate the variance of a NumPy array. Okay, so suppose we import the NumPy library, and now we want to calculate the variance of some football.
Then you just specify here. Still giving me the same mistake.
Football goals. So we have goals in 5 matches, and suppose we have goals of Croatia, and we create a NumPy array with the value 0, 2, 2, 0, 2. Okay, and we have some goals of France, and we also create a NumPy array of some values, and France has not quite so many goals. Okay, now we have the two NumPy arrays, goes France and goes Croatia, and we want to calculate the NumPy array. So suppose in C we store the variance of goes Croatia. Okay, now we can print the output of C, and you can see, yeah, the variance is 0.96, and so basically the variance is the squared standard deviation. So we first of all it internally calculates the mean value of the NumPy array, and then it calculates the deviation of each of those values to the mean value, and then it sums up this deviation and takes the square root. And the variance is the squared square root, basically, so the sum of all deviations. Okay, and yeah, if you calculate the variance of France, we also use the call npvar goes France, and you can see that if you print France, the variance should be smaller. Yes, so basically you can say it's more, as France shot less goals overall, the deviation from the mean is not so significant than the goals from Croatia. Okay, that's it. That's how you calculate the basic variance. You can also use a more advanced one. So suppose we have a two-dimensional array, like just call it A, is a NumPy array of 0, so 1s and 2s in the second line. So we have 2 lines, 2 rows, and 3 columns in this array. And now suppose you want to calculate the variance of along the first axis. Now we can simply put in A and
Maybe that's the thing that is missing. And the issue is so it's gonna know that it's from this list. Unless I tell it somehow.
X is 0, and now you can see that it calculates for each. So it has 3 values, and each value is the variance along the axis. Here, along this axis 1, 2, the variance, of course, the mean value is 1.5, so the variance is 0.25. And as we have the same 2 values along this axis, we basically have the same variance for each value. So, and if you specify x is equals 0, this means that you will get as many values as there are in the zeros axis. And the first axis. Yes, okay, that's it. So you can we can also calculate the variance along the second axis. And you can see as the second axis we have 2 rows. So now
Maybe we should do it separately. It's working. But it's gonna get the mean of the whole thing. That's what I don't understand. This one is out of bounds for array of dimension 1. Hmm. Maybe I need to do something before to make it 3 by 3. That's the problem.
Hi everyone, in this tutorial I'm going to be showing you how to convert Python list to NumPy array. First thing that I want to do is to import array from NumPy module. For example, I'm going to create a list, let's call it my list. This list is going to contain a few float point numbers, and now we want to convert this list into NumPy array. To do that, I'm going to use array function, and I'm going to convert this list into array. And this new array is going to be called, for example, NumPy array. And finally, I want to print it to show you that this array is successfully created. Let's run this code. And here we have that our list is successfully converted into NumPy array. That's all in this tutorial. Don't forget to subscribe to our channel and check other videos.
But in Python, the implementation of a two-dimensional array is quite easy. Actually, called tuple, and the main difference between is a list, right? So now I have a main list too, in which the elements are also list. So this and x in range.
Hello, I'm Landon Schlungen, and today.
Hey everyone, welcome to the next lecture. In this one, we'll talk about how we can start indexing our NumPy arrays and how we can reshape them. Let's get started. We'll go ahead and import NumPy as NP. Now let's make a simple array. We'll say array A is equal to a NumPy array, and we'll give this one the shape of 2, 3. So we'll say 1, 2, 3, and then 4, 5, 6. So now we should know that this one has a shape of a tuple 2, 3 because it has 2 rows and 3 columns. We'll go ahead and verify this. So we'll print array A dot shape. We'll save our file and open up a command prompt or a terminal, and I'll type Python 3 NumPy indexing lesson 1.py to execute, and we see that we get that tuple of 2, 3. Now let's talk about a new attribute to our NumPy arrays. Every NumPy array has a size attribute. The size attribute is just the number of columns times the number of rows. So since we have 2 rows and 3 columns in this array, that means we have 2 times 3, which is equal to 6. We can see this in our terminal, so we'll say array A dot size and print to our terminal. But what does the size attribute mean for us? If we reshape an array, the sizes must be the same before and after we reshape it. Let's go ahead and make a new array. We'll say array B, and we'll reshape this from array A. We can use the method reshape, and this is a function that takes 2 arguments. The first
is just shape.
first argument is the number of rows, and the second is the number of columns. So since we have a
3 by 3. It's giving me unexpected event. Maybe I have to erase this shit here. 147. Oh, so it's correct, I guess. At least the answer is correct here. Seems like. It's showing array then the thing. So maybe this should be wrapped up in this. I don't know. No, doesn't change anything. I think I will just watch Lando's solution, to be honest. I don't really feel like spending a bunch of time. Seems pretty simple. Just find each method and then apply for column and row, and then for the whole list. It's just a matter of figuring out the indexes for each one.
The size of 6, we only have a few options. We could reshape this to 1 and 6, so 1 times 6 would still give us the size of 6, or we could reshape this to 3 and 2. If we were to try to reshape this to 3 and 3, we would get back an error because the sizes are inconsistent. So we'll leave it as 2, and then we'll print array B. We'll save this and execute it. And now our array has 3 rows and 2 columns, but maintains the size of 6. In this example, all we've done is switch the number of rows with the number of columns, and that's a transpose. In NumPy, we could have just said capital T. We'll save this, and we should get the same result that we got before, which is exactly what we get. So now we should know how we can reshape our arrays and how we can transpose them. Let's talk about how we can pull out specific values using indexing. In NumPy, indexing is done by using integer values in square brackets. We'll talk through a couple examples. So we'll say print array B. So we're using this array that we just created of shape 3, 2. We'll use the square brackets, and let's say that we wanted to pull one row of information from our NumPy array. We can do this by using the index position of that row. So in our example, 1, 4 is in the 0 index position because NumPy starts at 0, 2, 5 is in the first index position, and 3, 6 is in the second. So if we wanted to pull the first row, 1, 4, we could just put a 0 here, save our script, and then I'll comment this one out, that way we don't get it confused, and print this. Now we returned only the first row in our NumPy array. Now let's look at how we can return an entire column. You're essentially wanting every row value, but only at a certain position. To do this, we could say print array B, and to specify every row in Python, we can use a colon. So we're saying every row, but we only want a certain column. So we need to specify the position of that column. In our example, we only have 0 and 1 because it's a length of 2. So in our example, let's get the second column, or the first index column. We'll use a 1, we'll save and print this. And now we returned 4, 5, 6, which was just every value in that second column. But what if we only wanted to pull out one specific value? We'll do this by saying print array B, square brackets, and instead of using a colon for every row, we'll say the first row, or the 0 index row, and the first value. So 0, 0. We'll save this, and we should be returned a 1, which is what we get. So now we should know how we can index values out of an array. If you feel comfortable with this, and also with transposing and reshaping arrays, then feel free to skip the next optional project. If you would like more practice, I'll see you then.
Today we are going to go through the data analysis with Python certification, and we're just going to start with the first project because this data analysis with Python has a bunch of video tutorials on how to do NumPy and how to do pandas, but I'm just going to start on the first project, and the first project is called Mean Variance Standard Deviation Calculator. So we're just going to hop right into it, click onto it, and then view the full project description, start code, and REPL.it. Reload if it's having a bit of trouble. Should work. All right, and here we have it. Here's the markdown for what we have to do, the assignment, and we need a function named calculate that will return a dictionary in this format. It takes in a 3x3 matrix that's in a format of just a list. So kind of weird there, it's not actually like a matrix, it's just a list, but it has to have 9 numbers in it. And then we have to output like the axis 1 mean, the axis 2 mean, and then the flattened array mean, and then same with the variance, standard deviation, the max, the min, and the sum. So this project's not too difficult, but it is kind of weird to just start working with NumPy. So let's take a look at this calculate function. We don't have anything in here right now, but we do have NumPy imported. So that's good. First thing we want to do is turn this list into a NumPy list. So we just do that with ls equals mp.array, and then we pass in the list. And then we can return a dictionary for now, I guess, and just copy this because it's what we're going to be returning. But I would just comment it out for now so that there's no errors. So now we have this list. I want to print the list just to see what we have. Print ls. Let's try running this. And it has to like update its packaging. All right, there we go. There's our list that printed out 0, 1, 2, 3, 4, 5, 6, 7, 8. And then it also ran the tests that we failed, but obviously we're going to fail them. So next up, we need to figure out the mean for the axis 1, axis 2, and flattened. How do we do this? Well, I'm just going to grab each part of the list and then find the mean of them. And I did it with this bit of code right here. See if the markdown has anything to say about this.
Oh, so it passes the list first and then .me.
Yeah, the markdown, how it has 3 numbers for the first one and 3 numbers for the second one, and then just 1 number for the third one, for the flattened one. So this is what we're doing for this. We're making an array, right? And I actually don't need these parentheses on the ends. I don't think. We're making an array, and we're grabbing the first 3 inside the list, and then we're finding the mean of those and putting them in this array, and then doing that for the 4th through 6th, and then the 7th through 9th numbers. And then we kind of do the same thing for the columns, except we get different indexes. So there we go. We grab index 0, 3, and 6, 1, 4, and 7, and 2, 5, and 8. So now if I uncomment this one, the mean, and I instead put mean rows in here. Actually, it wants mean columns first. It wants columns first, and then rows. So mean rows after, and then the flattened one, all we have to do for that is do ls.mean, and that should work for that. So let's try running.
So it should be lp.mean here. Let's see if this is lp here as well.
Running that now. For some reason, it's not printing this out. Oh, maybe it's underneath. Clear the console and run it again. Okay, there we go. There's our mean. 3, 4, 5, 1, 4, and 7, and then 4. If we look at the markdown, that's the same as what they have here.
I guess the way I was doing before was working. This is just another way of doing it.
So this works great, and we kind of just repeat the process for variance, standard deviation, max, min, and sum. It's not too difficult. So what I can do here is I can just copy this down, with option shift down, and then option down again to bring it lower. And then all I have to do is change the mean here, grab all the instances of mean with command D. It might be different for Windows, and just change it to var like that. Now it's variance. And then we can uncomment this, and variance will equal var rows, var columns, and flattened will be ls.var, and let's try running that. And here's our variance. Kind of hard to read, but yeah, it's 666, and then 2/3, 2/3, 2/3, and then 6.67, which I believe is the same as what they have in Markdown too. So that's good. Next up, standard deviation.
So we got the list, and then he did. Oh, he didn't do a reshape, I think. Yeah. Zero, 3, 6. 1, 4, 7. I got the other way around, I think. These rows and columns. Yeah, so I guess this is just exactly the indexes of each row. Yeah, this is the first column, 0, 3, 6, and first 7, 6, and first 7, and 2, which is the 0, 3, 6. Damn, my brain's not working. Two, 2, 5, 8.
Same process.
Well, that's because it starts at 0. So. I think for the other ones, it's as simple as changing each thing. So here's var. Var standard, I'm not really sure. It's columns first, rows second.
And I can literally do the same thing for all of them. All right, so standard deviation is just SDD for standard deviation. Max is just max, min is just min, and sum is sum. And yeah, we just put them inside these arrays, and then we can
Now let's see if it passes. Hopefully it does. So I have to transform.
You can run it and it will print out and should complete the tests. So let's try it. Clear the console, run it, and it still failed. Oh yeah, one more thing. Yeah, index 7 is out of bounds. That's because they're using an array with only 7 numbers instead of 9. So we have to handle that case. And it also says we have to raise, it says make sure we have a value error and then list must contain 9 numbers. So the way we raise a value error in Python is just by doing raise value error, and then we pass in the message that we want it to say.
It's weird
But we
that-
only want to do this
It's weird that it didn't reshape and it still worked.
if the list is not equal to 9 in length. So there we go. If length of the list is not equal to 9, then we raise a value error of the list has to contain 9 numbers. And now if we run it, we should complete all the tests. Yep, ran 3 tests and we completed them all. This is what we get for the output. And yeah, this one wasn't too bad. It was a
That's weird. Oh, that's why. Oh, array. That should be array. No. And p dot array.
good introduction to using NumPy. Being able to access array values using the
Oh, I have to import maybe. Yeah. To import NumPy. So I can't use this because it doesn't support. Nice. Oh, I know what I'm doing wrong. That's the problem. Maybe. Maybe not. it's inside the list that I need to do it twice. That's why it's confusing. Okay, so that was the problem. So now I have to do this for all of them. I think when I only put one, it understands that I'm passing 3 lists instead of giving 3 different indexes. And when I do it like this, it passes only one list with 3 different indexes. Hopefully now it passes. Nice. Okay, I'm gonna go to the other one right away. Probably gonna look at the Linus solution again. Just because I don't feel like spending a bunch of time on these challenges. Like I did on the previous ones. Must analyze demographic data using pandas. You are given a data set with demographic data that was extracted from the 24 census database. Here's a sample of what the data looks like. So I need to analyze this. Education. You must use pandas to answer the following questions. How many people of each race are interpreted in this data set? This should be a pandas series with race name, names as the index labels. This column. What is the average age of man? What is the percentage of people who have a bachelor's degree? What percentage of people with advanced education make more than 50K? What percentage of people without advanced education make more than 50? Blah, blah, blah. Use the starter code in the file demographic data analyzer. So I need to read the file. Something like this. Probably like this. I already forgot all the lessons. Maybe I should search for the lesson that as data series. Maybe it's this one.
And now it's time to read data from databases. We have already done that in our real example with Pandas part of the tutorial, but I want to show you a little bit more details so you understand how data is being processed in case this is a common scenario from you, importing data from databases. So the libraries you will need, first thing, depending on what database engine you're using, Postgres, MySQL, Oracle, etc., you will need to install different libraries. But the APIs, once you have installed those libraries, are going to be the same. There's actually PEP from Python that actually defines the interface for databases libraries, and Pandas can work with pretty much any database of these SQL common databases that comply with that interface. In this example, we're going to use SQLite because the database right here, there's nothing, no server to connect, etc. It's extremely simple to get started. And the example we're going to use, or the database example we're going to use, is actually a different one from our previous database rating. In the previous one, we were using Sakila. In this case, we're going to be using Chinook, which is smaller, both in structure and in size, so it's going to be a little bit simpler. So to get things going here, the same thing that we did with our previous part that was how to read data from files, I show you how to actually read data using Python. So forget about pandas for a second. I told you if we go back again to the beginning of time, there was no pandas. This was the way we were reading files. Open, FB read lines, etc. So I now want to show you what predates to pandas. What was the default way to read data before pandas, which is with the regular, again, interface from Python. So the way it works is we're going to import SQLite 3. We're going to create a connection. And now with this connection, we have these common interface that, again, is common for pretty much any other database that you're used to. And the default behavior is we're going to create a work with pandas. With pandas, we have a read CSV method. We also have a read read SQL method, and also what types to table. Read SQL query is the default behavior, what we've done so far. So in this case, it's just going to issue a query and the connection is going to read it for you. In contrast, read SQL table is going to read an entire table. You just pass a name, and it's going to automatically give you all the information for it. So in this case, all the column names, etc. So it's a lot simpler to read an entire table. The only thing to keep in mind is that to use
So I guess here are the columns. Maybe there. Well, that's the problem. Maybe I have to do something so it doesn't read the. No, it has to read the red.
Hey guys, and welcome to the Hackinon's YouTube channel. In this video, we will see how to read specific columns from CSV in Python Pandas. Are you facing problems when you want to read specific columns from your CSV data? We have a solution for you. Many people who are working with CSVs have a lot of things in common and face difficulties and need an easier way to read data from their columns. In this video, we will work with the Pandas model present in Python that is highly used for data science and machine learning projects and is also known for working with CSV data. So first things first, before I import the Pandas library, I would like to install it to my local machine. For that, I will go on my command prompt and I will simply type in pip install pandas. As you can see, for me it says that requirement already satisfied since I already got pandas installed into my local machine. So you can go ahead and install pandas. Let me close this. Now, I'll just show you the data that we will be working with in this video. So I have created a CSV data that stores data in the form of rows and columns. In the columns, there's a section name, and in these name section, there are a set of names along with their corresponding age and the salaries that they obtain. And this is just a random data set I have created so that we can work and understand how to gain certain data from our CSV files. So let me go back to my code editor, and in the first line, I've typed in import pandas as pd. And now I will create a variable called as dataset, and I'll say pd.read CSV. So read CSV is a function that is specially used to read data from a CSV file and import it inside our code. For that, in the argument section, I will put the name of
Okay, so this one is correct. Okay. Guess I need to clean the data somehow.
Of the CSV that I'm working with. And as you can see over here, the name of my CSV file is book1.csv. So in the arguments, I will say book1.csv. And now let me just print my data set. If I press and run the code, as you can see in the output window, the whole data present inside our CSV file is present. Now we also have another function called as head, and this head is used to return the data of the first 5 rows present inside the data set we are working with. So if I run this function, as you can see now, only the first 5 data that we are working with inside a CSV file is visible, and the other set of data isn't visible. Okay, so now let me delete this, and let me talk about the highlight in this video that we will be talking about, that is the iLog feature. So it is called as .iLog. Okay, so this function allows us to gain input in the form of a single one-dimensional matrix or a two-dimensional matrix. So let's say I want to gain in the data of all the age of the people. Okay, all the age of the people. For that, what I'll say is data is equal to my current data set that I'm working with, and then I will say .iLog, open my square brackets, and now I will do the simple work of slicing through my data, how we do usually through a list. So first I'll put a colon, that will be the start index, then I'll place a comma, and then I'll say 1 and colon 2, and then I will say dot values, which means we are trying to tell Panda that we want this set of data and that values corresponding to the data saved. And now if I print the data and run the program, as you can see, we will get a 2D matrix of only the age of every person present inside the data we are working with. Again, you can make changes based on your liking inside this data present. For example, if I remove the first colon and the comma and I run this code, as you can see, we are getting the data of Tom, that is the person present at the second index. Okay, since we sliced through this method, if I change the index to 4, and now if I run the program, you can see we are getting the data from index 1 to n-1 till 3. Okay, so based on this slicing method provided by the iLog function, you can slice in any amount of data, and this data will be available in the form of a 2D array or 2D matrix. Hence, the iLog param in CSV is about 4 times faster and uses almost half the memory used in a program. This means we have provided a simple method to obtain certain data from our CSVs. If you like this video, do drop a like, share it with your friends, and subscribe to the Hackinons YouTube.
I guess I'll look at the solution from Lando. Maybe I'll look at this one this time.
Hello, today I'm going to solve the frequently counted analysis with Python projects. So this is the second project. So let's start it. Here they actually give us questions, several questions. So I'm gonna explain and take data from this CSV file. I'll show it, and we're gonna use our test module here. Okay. So just firstly, from here, what they want, just come here and start from here. Okay. So firstly, we should read our file, right? So read CSV, yes, and here, that's it. Okay, it will read it. Okay, so they ask how many of each race are represented in this dataset. So I'm just going to check the column name. Okay, so I can say yes. You can see, you can show it. Okay, so there's my race here. So you can see my column name just as they ask. Okay, so I'm gonna say idf print my race column, and then value counts I will use, and I'm gonna do it like to list. Okay, I forget parentheses here. Okay, that's it. Okay, so no, next one. Okay, that's it. What is the average of the main? Okay, you can actually say idf df, and this is my column name here for finding the man or female here. Okay, so the important thing is just look at the it's big character or small. Okay, so I'll say okay, this is equal male, right? Okay, so then I will take my age and let's just go another line, and I can use here numpy, okay, for the mean. Import numpy as np. So we go numpy mean, and I want these data here, so it will actually find the mean of this one. That's it. This is just this question, okay? But here actually they found this value in a rounded. Okay, so I'm just going here, write round, and I will say okay, just one decimal. So that's it. Just check it. You found something or not? Okay. Okay, it doesn't appear because I actually forget to call my function. Okay, calling here. Yes, that's okay. It will work now. Yep, we find the average of the main as they want. Okay, so what is the percentage of people who have a bachelor's?
Don't understand what she did here, but I guess on the list is sex, the title, but the test asks for male. I don't know. Just copying what she did there. So I got a mistake already on this line here. I'll look at that
Okay,
later.
so let's
Yes.
find firstly my column here. So okay, here's the education, bachelor's, it's going like that. Okay, so I'm gonna use the name of this column. So df, you find my column where I data's here, and I will take the length of this one, so for using it. And actually I will say here, okay, for the bachelor's degree I can actually do something like that. Hi df, again, I want to just find bachelor's. Okay, so again in parentheses, so it actually finishes. Okay, so what about my total education? Okay, then I just need this, yes, and then take the length of this one. So maybe you can find another solution for this question, but for me it's the simple way. So for the percentage bachelor's, I want to say okay, tab, and it will equal percentage bachelor's divide total education. So I will again run it, because when we are going to test this codes, I don't want to see an error. Okay, so yes, just one decimal. Okay, I finished it. So another question: what percentage of people with advanced education, okay, bachelor's, master's, or another, make more than 50,000? Okay, so actually I thought it a little bit. I will write the code here. Okay, I actually thought maybe I can do it like that. Hey, I can use a log for finding the index. Okay, so idf application and string, which starts with B, I mean bachelor's, and M and D, not and. Actually, this is or. Okay, so then after that I say, but they should get a salary with this one number. Okay, so that's it. I will pass the lower education for now. I will say who have actually degree of bachelor's, master's, but they actually can get bigger than 50 or smaller than 50. Okay, so higher education, this will be the second one, but I will just take it from here to here. Okay, so take it. Yes.
This one's gonna be annoying.
So we can find it now, our percentage, like the before one. Okay, I wrote it. And also I again rounded this number, so length of the higher education and length of the
Guess I gotta know. She's just taking which one starts with each letter, making the or conditional statement.
a second higher education, and then I take the just one decimal. Okay, so
Wanna see the last line though.
actually we can see the answer from here. So we should find so
So it's D, done. The last conditional statement is for salary more than 50.
okay, so take it. Yes, so we can find it now, our percentage, like the before one. Okay, I wrote it, and also I again round this number, so length of the higher education and length of the second higher education, and then I take the just one decimal. Okay, so actually we can see the answer from here. So we should find just this percentage of 16. Okay, so lower education actually is similar, but I actually want to show a different way. So I firstly wanna look at the here IDF log and IDF, then show the we will get the salary. Okay, so and I will find the lower education as like that. Hey, give me the first number of this one. Okay, so actually this actually has the all of the education degrees, right? So lower education. Okay, and I will actually subtract from the range of the higher education, who actually have bachelor's, master's, or doctorate. So you can now find, okay, this is minus, you can now find the lower education, right? This is total, this is just what I don't want. Okay, so now this is the very easy question now. Okay, here I actually find the lower education, okay, as they want, but actually I found the whole education also here, total education, right? So I wrote it and then I said, okay, minus higher education 2. Okay, so you can now find the percentage of these lower education rich people. Okay, next questions. What is the minimum number of hours a person works per week? So let's think of it. We actually can use the minimum here. So I'm gonna write IDF find. Okay, what is it? Column name here. Yes, hours per week. So copy it, and that's it. Then I will say just find the minimum of it. Okay, so we can see it now. What is the number of it? So here 1 hours per week. Okay, so then they ask what percentage of the people who work the minimum number of hours per week have a salary of, and then they will get it actually bigger than 50,000. Okay, wow. So now actually I know the minimum hours is the 1 hour, right? So I will say, so minimum work df.log and df, I'm searching the hours per week. Okay, so and I want it should be equal to the 1. Okay, so then number minimum of workers, hey df.log, then what I will say here, okay, we can actually take it from here. Okay, yes, not more parentheses I don't want, and I want to say, hey, I should use here and operator, then I should say it should be actually salary condition. Okay, so take the salary condition here, so now I can find the reach percentage. So hey, range number minimum workers and over range minimum work. Okay, so actually again I'm going to run this number, and that's it. So normally, of course, I taught these questions before, Okay, so just don't look at the answers and try some way and then get help from here. So the other question, what country has the highest percentage of people that earn bigger than 50? Okay, so they want actually a country name, also the percentage. Okay, I think this is the hardest problem in here. Okay, so what I'm gonna do here, I actually find, try here, I need df and df.look. Again, I actually take this condition. Okay, I don't wanna lose time here. Okay, yep, take it. Okay. Oh, okay. So then I want to find the country, but let's check if the country is, where is it? Yes, okay, native country. Okay, here is our country. So yes, native country, find, and then actually get this one, put together. Okay, so after that, I just want to find this one, native country, but they don't have to take a salary bigger than 50. Okay, so again I will say value counts because it can put together the same country. So now actually the hardest part finished. Okay, so I will actually want to find what is the maximum percentage in here. Okay, now I can find the country like that, but after that I should find the percentage. Okay, so maybe we can find firstly country. Okay, here I will divide new df over new df2. So I want to say, hey, sort my values, and I will use the ascending. It should be false, so I can see the highest earning country. Okay, so and I will take the first one. So I said index 0. Okay, it finished. We can see which one. There's a mistake. Okay, we can use here another parenthesis. Okay, so start. I forget the number. Okay, start. Yes, the highest actually percentage of the rich country is iron. Okay, interesting. Okay, now we should find the percentage. Exactly a number we should find. So let's say, hey, richest should equal new df divide the new sorry, df2, and now find my so richest and maximum value from here. So we can now write here richest, right? So round also the number. Let's check it. I forgot. Okay, this is actually belong to the this country, right? Okay, so the last question is here. Identify the most popular occupation for those who earn bigger than 50, and we should find people from India, right? Okay, so what can I do here? I actually just find the India country and occupation column. Okay, let's write in India df.log and then df. I'm not going to write again. It will be the same. Okay, yep, and also I will use the AND operator here, and I will say, hey, df, choose my column of native country, and it should be equal India. Okay, then I will say find their occupation. Let's check if this is the true column name or not. Where is the occupation? Where is it? Didn't see that. Yes, there. So occupation here. Okay, so it will find country and their salary with this condition, and it will find also their job. Okay, so I will actually want to use here mod. So what should I write to first part? Maybe not from the statistic, but I can take from the pandas series to find their frequency. Okay, so because they actually use like this most, right? Okay, so I say mod, hey India, and give me the first one. So that's it. We actually finish it. Yes, this is the prof specialty. This is the top occupations in India, and they actually get this salary, and we finish all of the questions. So let's check these are true or not from the test
Mine gave me an error.
module. So let's go here, delete, and that's it. Yes, we can run it. Okay. Okay, I just get an error from here because of the name of it. This is just a easy problem. So let's look at it again. Okay, it will check it. It will check it. There's no error. Okay, just one error here. What is it? List object has no attribute to list.
Should be
Here.
with caps.
Okay, let's look at it.
Over there.
Okay, I will take it from here because I wanted to see something like that, but it's okay. I don't care. Okay, because it will show is like that, so there should be no error now. Yep. Yes, I saw the okay. So that's it. This is just if you want to ask something, you can comment and like it, and that's it. This is just an exercise from this website. So this is very.
Don't think mine is gonna work. It's showing up some errors.
We'll check it. Check it. Pandas.
Oh, now the India error disappeared.
Series to find their frequency. Okay, so because they actually use like this most, right? Okay, so I say mod, hey India, and give me the first one. So that's it. We actually finish it. Yes, this is the prof specialty. This is the top occupations in India, and they actually get this salary, and we finish all of the questions. So let's check these are true or not from the test module. So let's go here, delete, and that's it. Yes, we can run it. Okay. Okay, I just get an error from here because of the name of it. This is just a easy problem. So let's look at it again. Okay, it will check it. Check it. There's no error. Okay, just one error here. What is it? List object has no attribute to list. Here. Okay, let's look at it. Okay, I will take it from here because I wanted to see something like that, but it's okay. I don't care. Okay, because it will show is like that, so there should be no error now. Yep. Yes, I saw the okay. So that's it. This is just if you want to ask something, you can comment and like it, and that's it. This is just an exercise from this website. So this is very fun, I think. Have a nice day.
So I got two failures on mine. Lower education and thus higher education reach. Maybe here is true stuff.
df and string which starts with B, I mean bachelors, and M and D, not and. Actually, this is or, okay. So then after that, I say but they should get a salary with this one number, okay? So that's it. I will pass the lower education for now. I will say who have actually degree of the second one, but I will use this number. So length of the higher education and length of the second higher education, and then I take
So it must be my higher education second that I made a mistake. Starts with base exception. What's up with that?
to just one decimal, okay? So actually we can see the answer from here. So we should find just this percentage of 16, okay? So lower
One
education
error
actually is similar,
corrected.
but I actually want to show a different way. So I firstly wanna look at the here IDF log and IDF, then Chongde. We will get the salary. Okay, so and I will find the lower education as like that. Hey, give me the first number of this one. Okay, so actually this actually has the all of the education degrees, right? So lower education. Okay, and I will actually subtract from the range of the higher education, who actually have bachelor's, master's, or doctorate. So you can now find, okay, this is minus, you can now find the lower education, right? This is total, this is just what I don't want. Okay, so now this is the very easy question now. Okay, here I actually find the lower education, okay, as they want, but actually I found the whole education also here, total education, right? So I wrote it and then I said, okay, minus higher education 2, okay? So you can now find the percentage of this lower education. Rich people. Okay, next questions. What is the minimum number of hours a person works per week? So let's think of it. We actually can use the minimum here. So I'm gonna write a IDF find. Okay, what is it? Column name here. Yes, hours per week. So copy it, and that's it. Then I will say just find the minimum of it. Okay, so we can see it now. What's the number of it? So here 1 hours per week. Okay, so then they ask what percentage of the people who work the minimum number of hours per week have a salary of, and then they will get a actually bigger than 50,000. Okay, wow. So now actually I know the minimum hours is the 1 hour, right? So I will say, so minimum work df.log and df, I'm searching the hours per week. Okay, so, and I want it should be equal to the 1. Okay, so then number minimum of workers, hey df.log, then what I will say here, okay, we can actually take it from here. Okay, yes, not more parentheses, I don't want. And I want to say, hey, I should use here and operator, then I should say it should be actually salary condition. Okay, so take the salary condition here. So now I can find the reach percentage. So hey, blanch number minimum workers and over blanch minimum work. Okay, so actually again I'm going to run with this number, and that's it. So normally, of course, I taught these questions before. Okay, so just don't look at the answers, then try some way and then get help from here. So the other question, what country has the highest percentage of people that earn bigger than 50? Okay, so they want actually a country name, also the percentage. Okay, I think this is the hardest problem in here. Okay, so what I'm gonna do here, I actually try here any df.
My lower education one is failing.
That's it. Yes, we can run it. Okay. Okay, I just get an error from here because of the name of it. This is just the
Everything else seems correct. Oh, I got it. I was doing length lower education minus length higher education true instead of higher education. Yeah, no, it passes.
easy problem. So let's look at it again. Okay, it will check it. There is no error. Okay, just one error here. What is it? List object has no attribute to list. Here. Okay, let's look at it. Okay, I will take it from here because I wanted to see something like that, but it's okay. I don't care. Okay, because it will show is like that, so there should be no error now. Yep. Yes, I saw the, okay, so that's it. This is just, if you want to ask something, you can comment and like it, and that's it. This is just an exercise from this website. So
Hello, I'm Landon Schlangen, and now is the time that we go and we're doing the demographic data analyzer. So just click on this. If you haven't opened it before, you can access it just by clicking this link. I opened it before and I don't want another one in my REPL, so I'm just going to go to it by opening up REPL.it and then going to my REPLs and doing the boilerplate demographic data analyzer. And here it is open. And the README shows us what we have to do. We have to analyze demographic data using pandas that was extracted from the 1994 census database. And this data has age, work class, a bunch of different categories. The table looks a little weird, but yeah, we have to answer these questions. What is the percentage of people who have a bachelor's degree? So let's try to do this. The file that we have to change is this demographic data analyzer.py. We import pandas right away, and the first thing we have to do is we have to read that data from the file. So this isn't too difficult. All we have to do is pd.read.csv, and that will read the CSV adult.data.csv, which is this one, which is a CSV file, comma separated value file of all of our data. So right here we have a age 39, bachelor's degree, never married, not in family, white male, who has a salary of under 50K and is from the US. So yeah, and there's just a ton of these. All right, so that's our data frame. Our data frame is like a bunch of series pasted together to make a data frame. And the way we find race count, I did it really weird before, but then I found the Free Code Camp forum and saw a different way that someone did it, and it was way better. And this is the way that they did it. They did df, so data frame, and then we find a race out of there. So the series of race, and we just do dot value counts, like so. And then if I run this, it has to install pandas. So yeah, up here, number of each race. So this is what we're returning, race count, but this is what we're printing. So if print data, this is what we're printing, number of each race, and then we just pass in the race count. So we have 27,816 white people, 3,124 black people, 1,039 Asian Pacific Islanders, and then 311 American Indian Eskimos, and other of 271. So yeah, the way I was doing this before, I was doing like for loops and stuff, I don't know, but yeah, this is way easier. Next thing, average age of men. To do this, we have to go into the data frame another time, just so that we can compare things. So we need the sex of the individual, where the sex equals male. And then after we do that, we find the age. So here it's basically only selecting the rows inside the data that are male, and then after it does that, we're selecting the series of age, and we take the series of age and we just do .mean and we round it to 1 decimal place. So that should work for that. Let's try running it, and for some reason it has to install again, which is weird. There we go, average age of men, 39.4. Pretty neat. Percentage bachelors. This one requires a couple of steps. First thing we have to do is we have to find the total number of people with bachelor's degrees. So I'm just going to do num bachelors equals length of the data frame, where the data frame of education, or the series of education, equals bachelors, and that should work for that. So that's the number of people with bachelor's degrees, and then the total number of people is the length of the data frame. And then all we have to do for the percentage is we have to round number of bachelors divided by the total number, so that'll give us a percentage, and we want to round it to 1 decimal place. And we also have to multiply by 100, so that it's actual percentage instead of just a decimal. So let's see what this gives us. Percentage with bachelor's degree, 16.4%. It's kind of cool, so not very high, I guess. Next up, we have to find what percentage of people with advanced education make more than 50,000. And then what percentage of people without advanced education make more than 50,000. So this is a cool way to do this. We go into the data frame and we find the series of education. So we go to data frame education and we do .isIn, and then we pass in bachelor's, master's, and doctorate into here. So this is finding all the people that have education of bachelor's, master's, or doctorate, and that's what it's giving us. Lower education one is basically the same thing, except there's a not in front of it, and the not symbol for pandas is a tilde right in front. So that's selecting everyone that doesn't have bachelor's, master's, or doctorate. Now we have to use this to find this percentage with salary over 50K. And this will take a couple steps because I don't want the line to be too long. So the first step is non-percentage rich, or non-percentage higher. And this is going to equal this higher education data frame. So we're actually using a different data frame than DF. So data frame is everything. The higher education one is a different data frame that only contains the people with bachelor's, master's, and doctorates. So we find those people and we find their salary, and we return them if it's greater than 50K, and then we find the length of them. So that's how many people make more than 50K and have a high education. So to find this percentage, we have to round this non-percentage variable, non-percentage of higher, divided by the length of higher education. So that's the total number. And we have to do times 100, and we have to round it to 1 decimal place. So that should give us our higher education rich. And I think I spelled this wrong or something. Okay, I don't know why that's squiggly, but let's just try it out, see what happens. All right, so percentage with higher education that earn over 50K is 46.5%. So it looks like it worked. Don't know why there's this green squiggly line up under here, but whatever, I guess. Next up, we have to do lower education. So I can basically copy this, paste it under here, and just do non-percentage lower. And then instead of higher education, just do lower education. And then I can basically copy this as well and just change higher to lower. We're going to change higher to lower, and that should work for that. See what it gives us. Lower education, 17.4%. All right, cool. Next up, what is the minimum number of hours a person works per week? This one is actually pretty easy. All we have to do is use a min function. So we're going to do df. So we're going to grab the series of hours per week, like so. And we're going to do .min, like that. And by the way, this hours per week thing, the way we're getting these is because in this adult.data.csv, that's what it is in here. So hours per week has these dashes in between, and then education is like this. So yeah, that's how we get that, just how we connect things. And then we have to find the percentage of people who work the minimum number of hours per week and have a salary of over 50K. So the number of min workers is the amount that make the minimum work hours per week. So we're going to just do length of the data frame, where we find the data frame of hours per week, where it equals the min work hours. That should work for that. Now the rich percentage is this question right here. So we're going to do the length of the number of min workers. Okay, yeah, I actually remember why I didn't use this length thing here now. We want this to be a data frame yet, so that we can do number of min workers and then go into this data frame and get their salary where it equals literally like greater than 50K. I know it's kind of weird, but that's how the data formats it. So the length of that, and we need to divide it by the length of the number of min workers, which is the total amount of workers who work the minimum number of hours. That's salary. And then to make this into a percentage, we have to do round and grab all this, and we're going to do times 100, and we're going to round it to 1 decimal place. All right, let's try that out, see what it gives us. Even if there's squigglies, it still might work. All right, percentage of rich among those who work the used hours is 10%. All right, cool. Now we need to find the highest earning country. So this one takes a couple of steps as well. This one was actually probably one of the most difficult ones for this whole thing. Actually, it is the most difficult one for this whole thing. So let's break this up. We're going to actually need to find the country count, and we're going to also have to find the country rich count. So the country count is just going to be what we did with the race thing up here. So I'm just going to copy that down, and instead of race, we're just going to do native country. So that will give us the counts of those. Country rich count, we find where their salary is greater than 50K, and we grab their native country, and we do value counts all the same. Next up, highest earning country. We use these variables to come up with that. We do country rich count divided by the country count, so the total amount, multiplied by 100, and we do .idx max. So that finds the highest, well, it finds the country that has the highest percentage of rich people. So let's actually try getting rid of this ID max quick, and I'm just going to print highest earning country, and it should be a series, I think. Yeah. So here's our series, and then these are the percentages. So we actually don't even have to do times 100, I don't think. But yeah, what ID max does, so if I do ID x max, it grabs the index. So the first column is the index, grabs the index that has the highest value. So I believe in this case it's Iran with 41.86, and that's what we actually have to find in this next one, the highest earning country percentage, which is supposed to be this 41.86. So it might seem easy to be able to grab that, which it might be actually. I wonder if there's like a value max instead of index max, or maybe we can just do max. So if we grab this, put it here, and just do .max, what will that give us? Let's see, try running that. So yeah, that gives us that percentage, and we actually just have to round it now. So that actually turned out cool. Just do round, and we will round it to 1 decimal place. Like so. And I have an unmatched parenthesis. Oh yeah, I need to add another parenthesis here. And there we go. Highest percentage of rich people in country, 41.9%. Last thing we need is top in occupation in India. So this one's not too bad. First of all, we have to find the total amount of people in India, or just find the people of India. So we'll go people of India equals data frame, and we grab the native country series. This equals India, like so. And then we have to find the occupation counts. So we'll go people of India. We'll grab this data frame, and we'll select the occupation, and we'll find the value counts. So this is a way to find the most popular occupation. I just realized I might have done something wrong because it's who earn greater than 50K in India, and I don't actually check for that the way I did it, but it ends up passing all the tests anyways, which is kind of weird. So let's try running it. Yeah, it does prof speciality, and it says okay for the 10 tests. So it actually is right, but I don't actually check those who earn that greater than 50K. So I think I can just do that right in here, possibly with an and. So if we do and data frame of salary equals greater than 50K, so that should find the highest earner people of India, and it should be the same value. So let's try running that now. And it actually I get an error because I use this and thing. Oh, I think I need to put parentheses around each of these. I think that's the problem. Let's try running it. Okay, it didn't show up. Oh, never mind, it did. And we get the same thing. Professor speciality. All right, so that's cool. And we're done, I guess. So this is a cool project for working with pandas and using it to basically query the data out of a CSV file. Yeah, pretty neat. This one is definitely a lot more difficult than the first one was, but we definitely learned a lot doing this as well. So if you enjoyed the video, give it a like, subscribe, and comment down below. I believe next up we have like a medical thing. Actually, we can take this, paste it in here quick, complete it. Yeah, next up we have this medical data visualizer, which I haven't done yet, but it looks pretty dang difficult. So yeah, that one should be good to do a video on, and yeah, I will see you next time. Peace.
I think I watched the video for this one as well, and then the next one I might do it, but try to do it by myself. The next 2 ones. I just don't want to spend a bunch of time trying to do this, because I'm planning to do some challenges after I finish all the Recode Camp sections anyway, so we'll leave just spend more time once I start doing these challenges. I just wanna get to the AI part faster because I'm curious. Then eventually I might come back and try to redo these challenges, but to be honest, I don't think I will. I think I'll try to learn this more in practice, and I'm trying to build something, a project or something by myself. So now I'm supposed to use a graph library to visualize data. This seems interesting. So I need to create this chart here. This BMI is bullshit. Should know if someone's overweight or not. So pretty much I need to get the data from the file, then create the columns here with each metric, and then put the number of people, I guess, on the y-axis. So this is probably the read, the name of the file. Then here is gonna be the F. Well, the F overweights already there. So it's gonna be PLT plot, some shit like that. Or a label. Overweight. Yeah, not sure. Maybe it's this. I think I'm just gonna see the solution.
Hello, I'm Landon Chung, and today we're going to go through the medical data visualizer. So just open that up, access the full project description, and start to
I'm
go
gonna stop after this challenge.
REPL.it. And here we go, we have it open. We have the markdown for us explaining the assignment. Basically, we have to use Matplotlib, Seaborn, and Pandas in order to make a couple of graphs. And the graphs should look like the examples like figure 2 and figure 1. So if I go into the examples, figure 1, and there's some different functions that Seaborn and Matplotlib. Pandas.read CSV, and then we read the medical examinations.csv.
Oh yeah,
and
I forgot the CSV.
that data looks like this. It has an age, height, weight, gender, systolic blood pressure, diastolic blood pressure, cholesterol, glucose, smoking, alcohol intake, physical activity, and presence or absence of cardiovascular disease. To add the overweight column, they have a thing here of how to do that. And I at first did it like this, where we divide the weight by the height divided by 100. and then we square it. That gets the BMI. BMI is by dividing their weight in kilograms by the square of their height in meters. So yeah, their height is in centimeters right now. So that's why I had to divide it by 100 to make it into meters, and then square it, and then divide it by the weight. And then we have to check if the value is greater than 25, then we have to have the value of 1 or 0. And to do this, we use a lambda function. We do dot apply, and then lambda x is the value in the overweight column. And basically, if x is greater than 25, then we do a 1. Otherwise, we do a 0. And that's what this is wanting us to do. So that's great. Next thing we have to do is normalize data by making 0 always good and 1 always bad. And we have to do this for cholesterol and glucose. So we do kind of the same things for these two. We use these lambda functions. Cholesterol.apply 0 if x equals 1, otherwise 1. Glucose, if
You need to look at this lambda thing. Because I've seen it before as well. I'm not sure how it works.
x equals 1, then we do 0, otherwise 1. It's actually the same for both of them. And now we have to draw our cat plot. And the cat plot is figure 1. So we have to draw something like this. But first we have to change the data in a way that it will like it. So using pd.melt, we have to use just the values from cholesterol, glucose, smoke, alcohol active, and overweight. So this is how to do that. We do pd.melt, so our pandas, or just pd.melt, and we pass in the data frame for the first parameter, and we go id vars equals cardio.
I wish this guy solved these problems on stream sometime. To see how fast he actually solves the problems in real time.
And cardio would be the 0 or 1 up here. And then the value vars is the cholesterol, glucose, smoke, alcohol active, overweight. And all of these values are 0 and 1 as well. So like smoking is binary, alcohol intake binary.
Probably doesn't take a lot of time. Seems to be experienced.
Glucose would have been 1 of normal, 2 above normal, and 3 well above normal, but we changed that right here with cholesterol. If it equals 1, then make it 0. Otherwise, it's 1. 1 would be bad in this case, like above normal and well above normal, and then 0 would be just normal. Now we need to group and reformat the data to split it by cardio, show the counts of each feature. You will have to rename one of the columns for the cat plot to work correctly. So the way to do this is like so. I'm guessing this is the renamed column, or we just add a total column that equals 1. And then we group by cardio, variable, and value, because this pd.melt thing makes a variable and value column in our our data frame. It's kind of weird. As index equals false dot count. This as index thing, its default is true, but we changed it to false. It says for aggregated output, return object with group labels as the index. Okay, so all we want is like cardio to not be the index or something. Something like that. Now we need to draw it with an sns.catplot, and sns is the seaborn. And if we look at seaborn.pydata.tutorial or /tutorial, this is all their graphs that we can make, and we're making one of these. So if we try and look for one of these, like right here, this is kind of what we're going to be doing, except a little bit different. We're just going to do sns.catplot and then pass in our data, have an x and a y, and have a hue and a kind, a bar probably. So let's take a look at what we do here. And this is what I did. We pass in the data as DFF or dfcat, the one that we made. X is variable, Y is total. So if we look at this, total is on the Y axis, variable is on the X axis. And then we have hue equaling value. So what hue does is it changes the colors of the two bars based on the value, and 0 would be always good, 1 would be always bad, I'm guessing, right? And then we have a kind of bar, so yep, bar chart, and column equals cardio. So cardio would be the two different graphs, so that must be what that does. Don't know a ton about this. These docs are kind of hard to read and like make sure everything is correct, but yeah, they just have this one example of it. So yeah, here they have the hue of class, and then it makes 3 different hues for the class. We can also change the style of it. If we do sns.setTheme, we can style it to like dark grid, or we can leave it as what it is. This is just default. If it was dark grid, then it would have like a gray background. So I'm just gonna comment that out for now. And then let's try running it, make sure there's no errors in here. It might take a while for it to update the package configuration, and then it should make a new file called catplot.png, and then we should be able to open it, and it should look like figure 1. All right, that took a few minutes, but we now have our catplot.png, and it looks like this, which is pretty much exactly what we wanted. It looks pretty much the same as figure 1, so that's cool. Next thing we have to work on is this draw heat map. Clean the data first of all, and to clean the data, it just means like, let's see if it's in the markdown actually. Yeah, it says height is less than 2.5th percentile. So this is what it means by clean the data. Just like make sure the height is within this quantile and make sure it's like, you know, on the inside of it. So like height is more than 97.5th percentile, and then weight is between the 2.5 and 97.5 percentile. So basically just take the center data. So they kind of showed how to do this here, and we want to do this with height and weight, and also with this app low, app high thing. So this is how we do that. df, and then we just select these ones, and then we select these ones, and these ones, and these ones, using the...
Just gonna copy that. And this is gonna take a long time.
and
It's there. Think I got it now.
sign. Calculate the correlation matrix. This is done with this core function in pandas, and they have an example here where they have a data frame like this, and then columns, dogs and cats, and then they do a correlation, and their method is histogram intersection, but we're actually going to use a different method, and then it makes something like this. We're going to be using the Pearson method, which does a standard correlation coefficient. I don't really know what that means, but it works. So correlation, all we have to do is take our df heat and then do that dot core on it, and then method equals Pearson. So that should work for our correlation. Now we have to generate a mask for the upper triangle. The markdown doesn't really give any hints for how to mask the upper triangle, but we actually use a numpy function for this. It's called triu, numpy.triu, and this does the upper triangle of an array. Otherwise, with trill, it would be the lower triangle of an array. Okay, so yeah, it does 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but then it just takes, it like gets split between the 0 here and the 0 here, and just goes down in a upper triangle. And this -1 here must be where to start. So yeah, it's usually 0, so that would be split evenly. But yeah, okay, so that's what that does, and we need to use it here. So we'll do numpy.triu, which means the triangle of the upper, and then we pass in our correlation matrix. Now we need to set up the matplotlib figure, and that's done with matplotlib, so plt, and we can actually go to matplotlib's docs as well. Just go to their tutorials on matplotlib, and then we have some sample plots and stuff. But yeah, the usage guide, this is how we set up a plot. We do plot.subplots, and it equals the figure in the axis. So this is what they want us to do. They want us to do plt.subplots, and then we can even change the figure size right off the bat. So if we do fig size, we can change it to 1212, so that'll be a square. It's 12 in height, 12 in width. And now we need to draw the heat map with sns.heatmap. And this is actually kind of weird, I will admit. So if we go to SNS, which is Seaborn, and we look up their heat maps, this is what their heat map would look like, right? If it had random numbers in it, but we can use some data. In this case, they take flights in the month and the year. So this is the Seaborn heat map function, and we have to use it here. We
Copy that real quick.
pass in the correlation data, looks like, the matrix. We have a mask on it as well, mask equals mask. And yeah, we can add in a mask onto this one. Looks like they have a pretty good example here. Square is true, anot equals true, FMT equals 0.1f. FMT, string formatted code to use when adding annotations, whatever that means. Center is 0.08, and C bar KWS equals shrink. And yeah, kind of confusing, but it actually works. If we go to figure 2, it should look like this. So I'm guessing the FMT stands for format, and if we do 0.1f, it stands for like 0.2. It should have it in that format. I have like 1 decimal place. Oh, it has a line width as well, which makes it spread out a little bit. So like there's this line in between each one. And yeah, and then we just save the figure. Somehow it knows that we want the figure of the heat map. I don't know how it knows that, but it just does. We make a figure and then Seaborn draws on that figure, and then we save the figure. So let's run it, see what it gives us. Looks like it gave us our heat map, and it looks good. Looks pretty much the same as this one, except the colors are a little bit different. Yeah, the colors are a bit different, but it's pretty much the same. And it had all the right values in it, so it ran the 4 tests just fine. Yeah, that's about it for this one. Not gonna lie, this this project was pretty dang confusing, and there was a lot of stuff to go through. We had to go through Seaborn, Matplotlibs, plots, NumPy, yeah, tons of stuff. Seaborn has a ton of different plots that we can do. We can do line plots, do bar plots, we can do color, different color palettes, we can do scatter plots, just a ton of stuff. NumPy has a ton of different functions, and I guess we just had to use this one, which is a little weird. And then pandas, we had to use this correlation function, and they didn't really give us any good hints in the markdown. So yeah, it would have been pretty hard to find on our own. But I think the purpose of this one was to just get you comfortable with using Seaborn and Matplotlib to plot different graphs. I was playing around with it a little bit as well. I tried doing this function, draw scatter plot, and then I just like put in my data frame and then X and Y of weight and height, style, have a hue to it, and then we save the figure. So if I run this inside main and run it again, then it should give me another image, and that image should be called scatterplot.png. So yeah, there we go. Here's the scatter plot that I messed around with. We have the height and the weight, different genders of people, and then if they're active or not. So up here we have someone that is about 250 centimeters in height, and they weigh about 85 kilograms. It's pretty neat, and I'm pretty sure that was part of the data that they wanted us to clean. It's like all these outliers is probably data that we cleaned off when we did this right here. But yeah, that's it for this one. When we're done, all we have to do is take this REPL link and we paste it into FreeCodeCamp. So go back to FreeCodeCamp, data analysis, medical data visualizer, and paste it in. Complete the challenge and go on. Next up, we have this time series visualizer, and it has a lot of the same concepts as the medical one did, just a lot of making like the same types of graphs as they did. So yeah, I'll see you when we do that one. Bye.
There's one error here. Cholesterol. If this passes now. Should have used Control D. Because this is the only one left. Maybe just say below. So heat map is wrong. Oh, guys, because the equal sign.
Of an array. Okay, so yeah, it does 1, 2, 3, 4, 5, 6. It's usually 0, U, which means the triangle of the upper, and then we pass.
Yeah, now it passes. So I had made this plus or equal, and it's the opposite. This is why it wasn't passing. Not sure whether or not I'm gonna solve this by myself, but I'm gonna take a break now. And I don't know when I'm gonna come back. So yeah, see you.